Hi, my name is Elizabeth, and today we're going to learn how to name compounds that contain polyatomic ions in them. So as you may know, or as your instructor might have already told you, you need to memorize these polyatomic ions. And I'm not just kidding, please memorize them. So we're going to learn how to name them now, since I'm assuming you already have them memorized, all right? So we have to understand that there are fixed metals and also metals that have a variable charge. The fixed metals are going to be the ones in your columns 1 and 2, as well as the exceptions like aluminum, silver, and zinc. So now that we know that everything else is going to have a variable charge. That means that the charge that they have may vary depending on what they're bonding to. So the first one we're going to talk about is a fixed metal with a polyatomic. So these have a fixed charge. And then we're going to talk about the variable ones in just a minute. So, following the normal rules of naming, something with a fixed charge will also have the first one just keep its name. So the metal is going to keep its name. And now your polyatomic will just keep its name too. There's no root and ide, it's just the name of the polyatomic. These are probably the easiest ones to name. So let's do an example. Let's say we have KNO3. So K, when you look at it in your periodic table, is kind of funny because it doesn't start with a K. It's actually potassium. So he keeps its name. And this here is nitrate. So he also just comes right down. And that's it. That's potassium nitrate. Very simple, right? So now comes the ones that are a little more fun to play with. So the first one, the metal, is still going to keep its name. And the second one is still going to just be the polyatomic name. But because we can have multiple charges on these metals, we need to find the charge of those metals. So we're going to use a Roman numeral for those charges. So how does that look like? We're going to do probably more than just one example because these are a little difficult to understand. So the first example is going to be CuSO4. So when you look at your periodic table, you're going to see that Cu is copper, so he keeps its name. And knowing your polyatomics, you would know that SO4 is going to be sulfate. However, we need to find the charge of copper in this molecule. So I'm going to go ahead and do that up in this corner over here. So we have CuSO4. We're trying to find the charge of copper, so that would be our X. Sulfate, the polyatomic as a whole, is going to have a -2 charge. So that means it's going to be plus -2. So now you just solve, it's going to be 0 because it's neutral, so solve for X. So X is +2. So this would be copper 2 sulfate. Just looking at it, you wouldn't expect it to be copper 2, but it is. So make sure you do your math to be able to figure that out. So another example is going to be CuNO3. So as you can see from our previous example, Cu is copper. And knowing your polyatomics, you would know that this is nitrate. So if we were to do the math again, you would have CuNO3. Cu is going to be your X. Nitrate has a -1 charge, and that's going to be equal to 0. So X is equal to +1. So here this would be copper 1 nitrate. So as you can see, these metals can have different charges depending on what they're bonded with. And that's how you name polyatomic ions.